Year 7, so this is the second lesson on scatter graphs and trying to understand the relationship between the different pieces of data. If you haven't already done the lesson 1, please go back and do that one before you carry on with this one. So just for a quick review, we looked at data yesterday and you plotted some scatter graphs and you were able to see the link between things. You were able to look and see whether patterns and things. So today what we're going to do is try and describe the patterns that we find, and we're going to be using the word correlation. That's 2 R's and 1 L. Correlation is it's just a word that means the link between the data. So to start with, I just want you to have a think. You don't have to pause the video, you don't have to write anything down, but there are 3 scenarios here, and what I want you to do is to think what would happen in this, and in your mind kind of be thinking about what the scatter graph would look like. So first one, the sales of ice creams as the temperature rises during the summer. So that's how many ice creams will be sold as the temperature goes up. The second one is the value of a mobile phone as it gets older. And the final one is the amount that you'd get in a maths test the further away from school that you live. So if you happen to live in Fordingbridge, do you get a higher or lower score than if you live in Lymington? All right, so let's have a little think about those. And we're going to start to look at different types of correlation. Okay, so here we have 6 different scatter graphs. Now there are 3 different ways of describing a scatter graph or a scatter plot. You can say that they are a positive correlation, a negative correlation, or no correlation. So a positive correlation is one where quite easily you can see that the line goes from left down at the bottom left to up to the top right. We're going for a slope going in that direction. Now, a strong positive correlation means that all the different plots, the dots, they are close together along that line. The closer to the line they are, the stronger the correlation is. And that just means that the data can be, you could say there's a better link, a stronger link between the 2 pieces of information. The second one there is a weak positive correlation, and that's, you can draw this line. By the way, this line is called the line of best fit. But you can draw the line, you kind of see the trend going there, but they don't fit very well. And that's called a weak positive correlation. There is a positive correlation. It is going from the bottom left to the top right, but they're not sticking close to the line. So that's a weak positive correlation. Then the opposite of the 2 things there, we have the strong negative correlation. That's this one here, strong negative correlation. And that means that it's going from the top left to the bottom right. And this one, you can see it's a strong link because it's close to that line of best fit, which we're going to be doing tomorrow. And it's going from the top left to the bottom right. And then you can see down here, we have a weak negative correlation. That's the line roughly fits, but the points, the plots are not very close together. So that's a weak negative correlation. They're both negative correlations, but one's better than the other. And we also have this moderate, and you can call things moderate correlations. You don't tend to very often, but you might have a moderate correlation. That means it's pretty good, but they're not all along the lines. And then the one that I think a few of you got a bit confused with in yesterday's lesson is no correlation. So if it looks a bit random like this, the dots are all over the place, and if you were to draw a line, you're not really forming any sort of positive or negative correlation. We say no correlation. And this is the kind of thing where there is no link between the information. So I don't know, you might have something like over here, you might have a really strong link between the data. Here, a strong link between the data. Here, no link at all. All right, and we'll look at some of those examples now. So thinking about those 3 big areas, so we've got the positive correlation, we've got the negative, and we've got no correlation. So the sales of ice cream as the temperature rises during the summer. The sales of ice cream, let's go back to these and think about the sales of ice cream. So looking at those 3 with the big arrows pointing to them now, which ones of those do you think would represent the sales of ice cream as the temperature goes up? Have a little pause and think, if the sales, so for example, sales are going to be on the y-axis, that's the vertical axis, this one here. If the sales are going upwards, then as the temperature goes up alongside it, that's also increasing. So this one here is a really good representation. Here we go. So this could be sales, and this could be temperature. So as the temperature goes up, so do the sales of ice creams. Okay, well, how about this next scenario here? The value of a mobile phone as it gets older. So the value is going to be on the y-axis, the amount of money the phone is worth. The x-axis, the horizontal axis here, is going to be the one that's telling us how much the phone is worth. So over time, is the phone going to get more expensive or is it going to get less expensive? Unless it's made out of solid gold or some sort of precious metal, it's going to get cheaper and cheaper and cheaper, isn't it? Until you have the iPhone 1, which you probably can't even buy, they're so cheap. So the value is going down of the phone, but the age is going up. And so that would be a negative correlation. Okay, so the age is going upwards, but the value, the amount of money, is going downwards. So that would be a negative correlation. What about this last one? Last scenario, the amount that you'd get in a maths test, the further away you live from school. Now, let's not be silly about it. Let's not imagine for a second that you're having to travel from Edinburgh every day and you're arriving 3 hours late for every test, and therefore you get a 0 in every single test that you do. If we're thinking realistically about it, and you're having to travel from, say, Lymington or from Boulder or Pili or something like that, it's likely, I would say, that there is no link between how far you're traveling and the score that you're going to get. I hope that makes sense. So we have positive correlation. The positive correlation is ice cream sales go up as the temperature goes up. So if the two things are going up, that is a positive correlation. The value of the phone, well, the age is going up, but the phone value is going down. So that's a negative correlation. And the final one, there's no link between the scores you're going to get in a maths test, dependent on the distance away from the school. So that would be no correlation. Okay, so now look at these three. Pause the video, decide which of them is positive, which of them is negative, and which of them shows no correlation. Pause the video, and off you go. Okay, so hopefully you've spotted that we have in our top left here, we have no correlation. Here, the plots are all quite random, that you couldn't really draw a straight line and sort of group them together. So this would be no correlation. So this is a graph trying to show the link between your IQ and your house number. Hopefully those people who live on things like the London Road, which can get to thousands, would be the most intelligent. That's obviously not the case. The next one over at the top right here, we've got your weight and your height. Well, I suppose that's a pretty easy one to think about. As you are taller, your weight will increase naturally, won't it? If you were tiny, 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 then you would have a small weight, even if you happen to love a good pie. So we can say here that this correlation is a positive correlation. Once one thing goes up, the other thing also goes up. Now, we were talking about the types of correlation, a strong or a weak correlation. You can kind of see roughly, if we're doing a very estimated version, that this one has a sort of moderate correlation. There aren't many that would be on that line at the moment. So this would be, it's still a positive, but it would be probably a moderate positive. And this one, the last one, I'm sure you probably noticed the pattern by now. You can see this is to do with the annual temperature to elevation. So obviously, if you stand at the top of Mount Everest, it's pretty chilly. And if you go down to somewhere, say in Kenya, which is at sea level, it's a lot warmer. Now, that's not always the case, but generally it's true. So we can say that as the temperature goes up, the elevation is down. So that's how high up you are. We can kind of roughly, again, we're doing very rough lines of best fit. On the second section, we'll do a bit more accurate stuff. You can see a correlation here, and that is a negative correlation. One thing is going down while the other thing is going up. Negative correlation. Okay, so what I want to do is you're going to draw two scatter graphs now. The first one is maths and art marks. I don't know why, but loads of questions seem to love maths versus art. Could you please try and draw this into your book? And again, I've given stags to those people who did this yesterday. Do this, draw the points, try to decide the correlation, and you can send me an email with your pictures for some stags afterwards. So pause the video and have a go. Okay, so if we cycle down, your graph should look like this, approximately. It might be slightly off, don't worry about that. But you can see there's an approximate negative correlation. So it does kind of go from top left to bottom right. But you can see, actually, it's not particularly clear. So we would say that it's got a moderate negative correlation.